In number one, we have a radical equation. So the way we solve radical equations is we isolate the radical. Just 1 second. Okay. First, we isolate the radical. Or I'll just write isolate the square root. And the second is we square both sides. And then we must remember that we must check. We always have to check our solutions. All right, so here let's do that. Let's get this by itself. So we're going to subtract 7 from both sides. And now we're ready to square both sides. So here we have x minus 1. And here we're going to FOIL this out. This is x minus 7 times x minus 7. So we have x squared, and middle term minus 7x minus 7x minus 14x plus 49. Now let's get 0 on the left side, so we're going to subtract x and add 1. So here we have x squared. Subtracting x from both sides, we have minus 15x, and adding 1, we have plus 50. So this is standard form, so we're ready to factor. And this factors into x minus 5, x minus 10. Check that middle term, we do get minus 15x. All right, setting these to equal to 0, we get the two solutions, x equal 5 and x equal 10. And now we must do our check, so we'll do that here. So first let's check x equal 5. Substituting back into the original, we have square root 5 minus 1 plus 7 is equal to x equal to 5. That's square root of 4, which is 2. 2 plus 7 is not equal to 5. Okay, so x equal 5 is not a solution. All right, let's check. Let's do x equal 10. So here we have the square root of 10 minus 1 plus 7 equal 10. So this is square root 9, that's 3. 3 plus 7 is equal to 10. So this one is a valid solution. So we have one solution, x equal 10. And number 2, start by isolating the radicals. So we'll subtract 1 from both sides. Now square both sides. Here we get x squared minus 2x plus 1. And here we just have 5x minus 9. And now we're going to get this in standard form. We'll get 0 on the right-hand side. So we're going to subtract 5x, so that'll be a minus 7x here. And add 9, so that'll be a plus 10. All right, hopefully this factors. Let's try that. All right, so we have minus 5 minus 2. And we get the right middle term, minus 7x. So here we have two solutions, x equal 5, x equal 2. And now we'll do our check. First for x equal 5, substitute in 5 minus 1 equal to the square root of 25 minus 9. That's 4 equal to the square root of 16. That checks. So this is a valid solution. Let's try x equal 2. Okay, so we have 2 minus 1 equal to the square root of 20 minus 9. Sorry, 10 minus 9. 5 times 2, 10 minus 9. All right, so we have 1 is equal to square root 1. So that also checks. So in this case, we have two valid solutions. In number 5, we have an equation that's quadratic-like. Remember, something's quadratic-like if this x term squared gives you this one. So x to the 1/4 squared is x to the 2/4, which is the same as x to the 1/2. So if we square this one, x power, we get this x power, it's quadratic-like. All right, so let's solve this. So usually what we do is we put y equal to the middle, this middle term over here, and y squared is x to the 1/2. All right, so that's what we're going to do. We're going to put y equal x to the 1/4. Y squared is x to the 2/4, or x to the 1/2. All right, let's rewrite. So instead of x to the 1/2, we're going to put y squared minus y minus 6 equals 0, and then we factor. Okay, so once we do this y substitution so that we get a regular quadratic, this one we call quadratic-like, similar to quadratic. Here we get quadratic, and we factor. All right, so let's factor this. So this is minus 3 plus 2. Okay, that gives us the minus 6, and that gives us the minus y in the middle. So we have y is equal to 3, and y is equal to negative 2. All right, and now we have to go back to this equation. Okay, and we want to know what x is equal to, so we're going to write x to the 1/4 is equal to 3, and here we're going to write x to the 1/4 is equal to minus 2. Solve these by raising both sides to the exponent 4. So we have x is equal to 3 to the 4th. 3 to the 4th is 81. And here again. And here we have x is equal to 16. And we must do a check. Whenever we square both sides, we have to check. And here we did exponent for both sides, which is also even. Whenever you raise both sides to something even, you must check. So we must do a check. The book advises to always check. Always check your answers in this section. So anyway, we will check. We want to check if 81. This one I do not think is a valid solution, because here we had x to the 1/4 equal to negative 2. Okay, so the fourth root of a number is positive, so just like the square root of something is positive, so I don't think this is a valid solution. But anyway, let's do our check. First, let's check x equal 81. So we're going to check is 81 to the 1/2 minus 81 to the 1/4 minus 6 equal to 0. This is the square root of 81, that's 9. This is the fourth root of 81, this is 3. And this is equal to 0. 9 minus 3 is 6. 6 minus 6 is 0. So that one checks. This one's good. Okay, let's check x equals 16. So there we have 16 to the 1/2 minus 16 to the 1/4 minus 6 equals 0. So this is 4 minus 2 minus 6 is not equal to 0. Okay, 2 minus 6, that's 2 minus 6 is not equal to 0. So this is not a valid solution. So we have one solution. All right, let's look at number 6. Again, quadratic-like. If you square that power of x, you get that power of x. So we're going to put y equal to the middle one, y equal x squared. And we get y squared minus 8y plus 15 is equal to 0. Okay, let's factor that. And we have y minus 5, y minus 3 equals 0. Y equal 5, y equal 3. And we should do a check. But this is just a regular polynomial. We never had to check those in the past. We're really not doing anything here that requires checking, like we're not squaring both sides or raising both sides to the exponent 4. So these do check. Okay? If you try it, they both check. So these are both valid solutions. Really, we check whenever at some point we raise both sides to an even exponent. That's when we have to check. Okay, we didn't do this here. We never raised both sides to an even exponent. Number 7 is again quadratic like. If we square this, we get this. Square root of x, we get this. Or we can treat this like a radical equation, isolate the radical, square both sides. All right, let's say we isolate the radical, square both sides. Let's do it that way. So we're going to isolate the radical term with the 3. All right, so we have 3 square root x on the left, and on the right we're going to subtract x and add 4. So add 4, we'll put the 4 over there, subtract x. Okay, so we rearranged it so the radical is isolated. You could have a coefficient in front, however. Let's now square both sides. Okay, we will have to check. We squared both sides, so we do have to check our solution. So here we have 9x is equal to, and here we're doing 4 minus x. I'll just put it on the side. This is what we're doing, 4 minus x, 4 minus x. So we have 16 minus 4x minus 4x minus 8x plus x squared. All right, let's just subtract 9x from both sides. And we have 0 is equal to 16 minus 17x plus x squared. I'm going to rewrite this with x squared first. All right, this factors into x minus 16, x minus 1. Okay, we get that middle term minus 17x. So we have x equals 16, x equal 1, and we must check here because we did square both sides right in the beginning, so we absolutely must check. So let's check x equals 16. Substitute into here. 16 plus 3 square root 16 minus 4, is that equal to 0? So that's 16 plus 3 times 4, 12. Minus 4, no, that's not 0. Okay, so x equals 16 is not a valid solution. Let's check x equal 1. And we have 1 plus 3 square root 1 minus 4. And we want to see, is that equal to 0? So this is 1 plus 3 minus 4, and that is equal to 0. So this is x equal 1 is a valid solution. In number 8, we have this term in parentheses, and here we have that term squared. So we're going to put y equal to that expression in parentheses. So we have y is equal to 5x plus 2, and we'll write this as a quadratic 2y squared minus 5y minus 3 equals 0. All right, this factors, hopefully. So here we have 2y, and we'll do 3 minus 3 and plus 1. Check that we get minus 5y in the middle. Here we have a minus 6y plus y, and that gives us that minus 5y. So we have 2y plus 1 equals 0. 2y is equal to minus 1. Y is minus a half. And here we have y is equal to 3. All right, we want to know what x is, so we're simply going to put x here and here. So here we're going, sorry, that's 5x plus 2. We'll put that here. 5x plus 2 is equal to minus 1/2.